Determine all values of theta to the nearest degree if theta is greater than or equal to 0 degrees and less than or equal to 360 degrees, given the following trig ratio. Sine theta equals 0.4815. Let's recognize that 0.4815 is a ratio, and what a ratio is basically a fraction. Okay, it's a fraction, and this can be rewritten as sine theta equals 4815 all over 10,000. Now all I did was multiply the top and the bottom by 10,000 just to represent this decimal as a fraction or a ratio. And you know that the sine ratio, the sine of an angle, is the opposite over a hypotenuse. So the relationship between the opposite side to this angle over the hypotenuse of the triangle formed is 4815 over 10,000, or 0.4815. Now, to find all values of theta that solves this equation, determining all values of theta that make this equation true, you need to first recognize that there could be more than one possibility. In fact, there are exactly two possible theta values. And to determine what those values are, you need to first look at the sign of this ratio. So what's the sign of this ratio? And if you just look at up front, you see that there's no sign here, so it's a positive. Okay, so positive. Sine theta is greater than 0. Sine theta is positive, or sine theta is greater than 0. Sine theta is positive. Sine theta is greater than 0. Therefore, well, according to the cast rule, let me just draw a quick diagram here. You know that the sine ratio of any angle, is positive within quadrant 1 and quadrant 2. Therefore, the values of theta are going to be located in quadrant 1 or quadrant 2. We're not concerned about quadrant 3 and quadrant 4 for this ratio. First, what we're going to do is we're going to determine the value of theta in quadrant 1. So theta in quadrant 1. So in Q1, we're going to determine the acute angle, which is less than 90 degrees. Determine the acute angle. We'll call this acute angle alpha. Alpha is equal to the inverse sine of 0.4815, and if you punch that into your calculator rounded to the nearest degree, this is going to equal about 29 degrees. 29 degrees. So therefore, we found our first angle, the acute angle in quadrant 1, and now we're going to find the angle in Q2. So in Q2, because we determined that it can only be in quadrant 1 or quadrant 2, because this ratio is positive. Sine is positive in quadrant 1 or quadrant 2. So in quadrant 2, therefore, your angle theta has the possibility of being 180 degrees minus the related acute angle alpha. 180 degrees minus 29 degrees, and that's going to give you 151 degrees. Let me just draw a diagram to help you visualize this. So our related acute angle, it's about 30 degrees, so I'm just gonna pick a different color. Your alpha is gonna look like this, 29 degrees. And that's actually also going to represent theta 1, or the first possibility of fourth theta. And your other angle in quadrant 2, this is going to be 180 degrees minus alpha, so this is also going to be 29 degrees, the related acute angle, alpha. And this over here is going to be 151 degrees. Okay, so therefore, theta equals, in Q1, 29 degrees, or theta equals in Q2, 151 degrees. This is all to say that when theta equals 29 degrees, so remember, we're basically solving equations. This is basically saying, so let me write this as an aside. Okay, when theta equals 29 degrees, or when theta equals 151 degrees, that's going to cause sine theta to equal 0.4815. It's going to make this equation true, positive 0.4815. So your solution is right here. 29 degrees and 151 degrees will make this trig equation, this trig ratio, true.